We've got quite a lot to get through. So talk today is about container security, Kubernetes and Docker. I got involved with Docker about 5 years ago, just over 5 years ago. And it was typically how you'd expect to see a new technology. It was a really early adopter. It was before Docker even hit 1.0. And that was fair enough, you'd expect that. But when I got involved with Kubernetes, it was in the really early days of Kubernetes, and it was a British government department. And it was at that point I realized, hang on a second, this is probably quite popular if you've got everyone from startups all the way through to the government making use of this stuff. So over the last couple of years, I've done quite a lot of container security work, and this talk essentially is about some of the things that can go wrong and how containers actually work, because I think there's still a bit of confusion in the industry about what actually are containers and how do they work. So we're going to talk about that as well. The very brief about me first. So I've been in IT and information security for about 19 years now, financial services and consultancy. I'm a principal consultant at a company called NCC. We've got an office here in Singapore, as well as offices at various places around the world. And most of the time these days I do container security work. I'm a contributor at Security Stack Exchange. Quick short, people heard of Security Stack Exchange at all? Okay, a couple of people, excellent. So it is a smaller and friendlier version of Stack Overflow. And we actually, I think, have 4 of the contributors to it who are actually speaking at this conference, which is quite a lot of us. So if you have any questions about security, container security or otherwise, feel free to go there. And you can also answer questions as well if you want to. And lastly, possibly most relevantly for this talk, I'm a contributor to the CIS benchmarks for Docker and Kubernetes, one of the authors. When I got started in container security, there was almost no information out there about how it worked. So we've got CIS benchmarks, which are moderately up to date. The Kubernetes one's pretty good. Docker one needs a bit of work. So those are available. As I'm a security tester, I get to work remotely. So I live here. This is Loch Goilhead in the Scottish Highlands. And it's a long way from here, I'll tell you that, having just traveled here. But it's very nice when it's not raining. So what are we going to talk about today? We're quickly going to talk about what are containers. Let's actually break down what containers are and how they work, because that's kind of important. Before you start talking about breaking into something or securing it, it really helps if you understand how it works. Very quickly go through Container Orchestration 101. So Kubernetes is very popular, understanding a bit about how it works. Let's just move on to the last bit, some container breaking and entering. Let's show you how we've hacked into clusters, how other people are hacking into clusters, and some of the things you need to get right to avoid it being you next. So what are containers anyway? They're not new, is what containers are. Containers are very much not a new technology. So containerization got started in 1979 in Unix with the chroot system call. So they're that old. And then around 2000, various operating systems started implementing some kind of idea of containers. So BSD first with jails. Linux got its first containerization in 2001, Solaris 2004. Then in 2008, LXC came along, which is still a project you can use today. And it was the ancestor of Docker. When Docker got started, they made use of LXC technology. They don't anymore. And in 2013, Docker was the first kind of startup of the Docker project. It took a while for them to hit 1.0 though. So it's not a new technology, but it is a popular technology. So this was taken from Stack Overflow, do a professional developer survey. And what they do is they surveyed 90,000 developers, and they said to them, what platforms do you make use of? Right. Number 1 is Linux. That's not a surprise. You know, most servers are Linux these days. Number 2 is not a surprise either. Windows. Most desktops are Windows, and a lot of servers are as well. But number 3 was Docker. So ahead of all the cloud platforms, ahead of all the mobile platforms, Docker came in as the thing that professional developers were using, which I thought was really interesting, because that's kind of come out of nowhere. You know, this thing didn't exist 6 years ago, now it's the 3rd most popular platform that developers use. Why are they popular? The first question you always ask yourself, where does this come? Why is this so popular? And this is a really good example. This is a really basic Docker command. This basically says, give me a web server, an Nginx web server, and expose the port and run in the background. And if you're a developer and you want to run any one of the 2 million plus images on Docker Hub, most of the commands are that simple. You don't need to know how the application was packaged. You don't need to know what versions of what libraries you might need to use. You don't need to know what language runtime you might need to use. You just say, Docker, run this, and it works. And it works the same if you run it on your laptop, as if you run it on your on-prem server, as if you run it on your cloud server. That, I think, is what, to me, is why Docker is very popular with developers. There's another reason, though. It's very popular with companies, and that's because of money, which is unsurprisingly, because companies like making money. These days, pretty much everyone deploys their stuff in the cloud, right? In AWS, Azure, GCP. When you buy an EC2 VM, you buy it by the hour. and you pay the same if it's 1% utilized or 100% utilized. So traditionally, you would have one application running in your VM, and with containers, what you can do is you can have 7, 8, 9, 10, even more than that, reasonably well isolated applications running on a single VM. So your utilization goes up, your EC2 bill comes down, and your company's happy because they're saving money on their cloud bill. What are they? We've said they're popular, but what actually are they? They're not a virtual machine. First thing when you're talking about containers, they kind of look a lot like virtual machines, but they're really not virtual machines. Usually. There's some edge cases where they might be. But let's talk about Docker because that's the West thing. And no, they're not usually. What they are is a lightweight process, sorry, a Linux process, isolated from the underlying host. So if you're thinking about securing Docker, attacking Docker, doing anything else, what you're doing is you're attacking a Linux process, the one that is isolated from the underlying host. That's all you're doing. And when you're thinking about securing it, anything you can do to a Linux process, you can do to a Docker container. It's exactly the same. So how do they do this? How do they actually isolate this from the underlying host? Well, the answer turns out to be they use a whole lot of technology that's been around for a long time. So I have my process here. That could be Nginx, it could be WordPress, it could be whatever. They then use namespaces. Namespaces have been around for a long time. They are a technology that essentially says you can only see this subset of resources. So if you use the mount namespace, you can say you can only see your own files. You can't see the files in the rest of the host. The net namespace says you can only see your IP address. We'll give you a new one. You don't get to see the real IP address of the host. And it ends up looking quite a lot like a VM. On top of that, you have capabilities. So one of the main complaints that gets thrown at Docker is they say, oh, well, you're root in this container. So obviously it's insecure. You're not really root though. So what they've done with Docker is they've taken the capabilities, which are a Linux feature, anyone can use capabilities, and it breaks up the root privilege. Instead of being just root, you can say, I want this one small piece of root. So what they do with Docker is they said, here is a subset of these capabilities. You just get these by default. And they are the less dangerous ones. Not all entirely not dangerous, but less dangerous. On top of that, they put C groups. So if I've got my containers running, and one container can take all the resource on my host, obviously that's not much good. So you can apply a C group to it to say you can only have so much memory, so much disk I/O, so much processor time. On top of that, they then layer either AppArmor or SE Linux. So as long as you haven't disabled SE Linux, like most people do, you will get an SE Linux profile on every container or an AppArmor profile by default. And then lastly, on top of all those layers, they said, okay, syscalls are dangerous. Syscalls is when you talk to the Linux kernel, you're making syscalls. Some of those are dangerous. So what we'll do is we'll create a whitelist of allowed syscalls and we'll get rid of all the ones we think might actually allow you to easily break out. And essentially when you do Docker run, it does all this for you. So it's setting up namespaces, it's setting up C groups, AppArmor, and seccomp profiles, and saying what capabilities you have. And that essentially gives you this level of this available, isolated environment. One of the really cool things about Docker is you can tweak every single one of those. So they give you defaults, but there's nothing to stop you saying, hey, I don't like what you chose. I want to choose a more secure or indeed a less secure default. But that's what it does. That's what Docker actually does. So what are container images? I said you could get 2 million of these things. Actually, took this off Docker Hub, Docker Hub is the app store of Docker. It's where all the images live. That screenshot says 2.1 million. I actually looked yesterday and there's 2.35 million different images on Docker Hub. All they are is tarballs. So if you know Linux tar files, that's all a Docker image is. It's a tar file with some JSON metadata. If you want to analyze it, use tar. You can literally use tar, untar it, and look and see whatever's in there. There's literally no magic there. So it's very easy. It's all just Linux technology. One thing you'll find out with Docker is everything Docker does is just Linux. There's nothing that's not part of original Linux. It's with some JSON metadata, and that's your images. What does Docker do then? So Docker works like this. You have a Docker client, so command line utility it used to run. It talks over a REST API to the engine. The engine says, hey, I'll talk to Docker Hub to get my images if I don't have them, or any other registry. And then I create these isolated processes, which are containers. So what Docker is really, it's a process running thing. All it does is it lets you run processes remotely or locally in a semi-isolated way. It's really not too magic. And it's just a REST API, so you can talk to it with curl if you want to. So Docker security. Very quickly, you have to cover, you talk about Docker security, you have to cover this. Someone in Red Hat coined the phrase containers don't contain. And they said, well, you can break out. And the answer is that it's not that simple. It's not straightforward. Are there vulnerabilities that could let you break out of a container? Yes. Are there vulnerabilities that will let you break out of any sandbox? Probably yes. you need to understand where those vulnerabilities are and when you might be able to exploit them. But the idea that containers just blanket don't contain isn't true to my mind. They do provide a decent level of isolation. For a lot of workloads, it might be a perfectly good level of isolation. So that's too simplistic. You will see that in any Docker security articles, I guarantee you someone will quote containers don't contain somewhere. How can you break out? So if you're running containers, how do you break out of them? Linux kernel vulnerabilities. So before when I said you're running against the same kernel, so I've got 10 containers running on a single host. They're all sharing a Linux kernel. If there's a vulnerability in that kernel, someone can try and use that to break out. They do have to get past all the layers of isolation we talked about, but there have been cases where that's possible. Exposed file systems. Typically with Docker, you will mount file systems for the underlying host into your containers quite a lot of time. If you do something like mount/etc, which is where all the system files live, inside your container, it's going to go badly wrong for you, and that does happen. The other thing is insecure configuration. When you get Docker containers from people and they say, oh, run my Docker container to do whatever you want, they give you some rather dodgy defaults, or rather some dodgy suggestions from a security standpoint. The first thing they'll do is they'll say, oh, we need access to the Docker socket. The Docker socket essentially is the API endpoint. If you give someone Docker socket access, you're giving them root on the host. So if you're thinking about it this way, if someone says, I want to expose the Docker socket inside my container, that's root on the host. Just treat it like that and understand that's what you're doing. Docker also has a really cool switch called ---- privileged. And ---- privileged is turn off all the security. See all those lovely layers of isolation? Bin them all. And unfortunately, quite a few people, well, that makes things easy, right? Because everything just works if I turn off the security. So you'll see commercial software packages containers, and they'll say run as privileged. Always challenge a vendor that tries to tell you that, and say, no, there's better ways than ---- privilege in almost every case. So to demonstrate this, and we're going to do video demos because it works better with the recording. Where's my mouse? Where is my mouse? It's there. Okay. Let's go full screen. So I'm going to run something called the most pointless Docker command ever. There's a guy called Ian Meal, and he came up with this idea. He said this is the most pointless Docker command you can run. I actually think this is the most useful Docker command you can run. I use it all the time. So I'm on one machine. I'm calling Docker on another machine. And I'll pause it there because I've talked this through. What this command basically says is it says run as privileged, the thing I just told you not to do. Give me the network of the host. Give me the process list of the host. Give me the IPC of the host, mount the entire host file system into my container as /host, and then change root to that. If you run this command, what happens is it basically says I can't find that image locally, goes off to Docker Hub and gets it. And then once it's run, it says, oh, you're root on the host. So I'm just the root user. So one Docker command, I'm now root on that host. I'm full proper root. I'm not constrained in any way, shape, or form. So I can do anything I want. So there's, I'm on the Docker host, and I'm running as root. And if I do PSEF, I've got a full process list. I can do anything I want to any of those processes. I am root. And that is, so Docker security is very nice, very flexible, but it being very flexible means you can take it all away. So you do have to be careful when you're using it that you don't just strip all the little layers of isolation away. Other things to consider about Docker security, where do my images come from? So remember I said there are 2.3 million images in Docker Hub? Of those, 270 are what they call official images, which are maintained by Docker and are supported or at least get updates from the vendor. The rest, so 2.3 million minus 277, could be anything. They could be malware, they could be cryptocoin mining, they could be literally anything. Don't run images from Docker Hub in production. Make your own images, have your own registry, maintain them yourselves, don't run from Docker Hub. I do pen tests on containers. This is like a free finding. A free finding is you are running images from Docker Hub that you don't own. Because people do, and they shouldn't. It's really dangerous. Just not a good idea. So that was my very quick whiz through Docker security. We're now going to talk about container clustering very quickly. So Docker is one host, right? Docker is one machine. I'm going to run Docker on a single machine, and I'll run the containers on that machine. Obviously, if I have a big company, one machine isn't anything like enough. I need 100 machines, 200 machines, 300 machines. To do that, you need some sort of clustering software. And that lets you, you need something that scales up over all those hosts. This is where Kubernetes comes in. There are other container orchestration systems, but there was like a kind of, it gets called the container orchestration wars like 2 years ago, and Kubernetes won. It's all over. Kubernetes won the war. It is now the container orchestrator everyone uses. Whether they should or not, they do. What you need to know about Kubernetes is it's very hard to define Kubernetes. So no one goes to the GitHub repository, clones the software, and installs it from that. They use an installer, because it's quite a complex thing. As of last time I checked, there are 109 different installers or software as a service providers who will give you Kubernetes. So from a security standpoint, I can't tell you things about Kubernetes security all the time, because sometimes it depends on the installer, right? Maybe they'll have a secure default, maybe they'll have a bad default. One thing I would advise you, if you're thinking about deploying Kubernetes, is find out what the defaults for your chosen installer are, because I've had some nasty surprises with big companies who you think would know better, putting some really insecure defaults in their Kubernetes installs. So don't assume that just because it comes from like some really well-known company, they'll get it all completely right. That's not my experience at all. It's very hard, and yeah, literally everyone's got a Kubernetes distribution at this point, as far as I can tell. If you're a big tech company, you have to have one. So what is it actually, how does it work? This is vanilla Kubernetes. This is the absolute most basic cluster you could have. It's a lot more complicated than Docker, but it's not too horrible. Everything here basically is REST APIs. So it's everything, they expose all these services, just an HTTP API. You can call it with curl, you don't have to use the tooling. The main thing, red component in the middle, API server. So that essentially is the heart of Kubernetes. Everything talks to the API server. It manages everything. If that goes wrong from a security perspective, you're going to have a really bad time. Because remember I said Docker is like a remote process creation tool? That's the same, except I can do something to 100 hosts or 1,000 hosts all at once. So if you get control of that, bad things are going to happen. Kubernetes doesn't store state itself, so it uses a thing called etcd, which is just a key value store. It's a fairly basic database, and it sits at the top there, and it stores all the state for the cluster. And the other really interesting component is down the bottom. So there's a component that runs on every worker node. So I've got kind of my master nodes that like manage things, and my worker nodes that run workloads. There's a thing called the kubelet, and the kubelet essentially manages Docker. So what happens is you say to the API server, give me 10 websites. And the API server says to 10 of its worker nodes, give me one website each. Go and do that. And that's the kubelet. And the kubelet then says to Docker, hey Docker, go and run a container for me. So typically I put in the right-hand side container engine. That's almost always Docker at the moment. It won't be in a year's time. People are like getting rid of Docker and putting other things there. But for the time being, it's always Docker, pretty much. So if you can control the kubelet, you can control Docker. If you can control Docker, that command I did before, that gives you root on the underlying host, will work just fine. So it's really important to get those three components security right, otherwise bad things happen. And an honorable mention to Kubernetes networking. Is everyone using Kubernetes at all? A little light, okay. So when you come to use Kubernetes, one of the things you'll find is the networking is a bit weird, is the only way I can describe it. If I've got like 100, say I've got 100 VMs, right? And I'm running containers across all of them. The container could get put anywhere. So I could have a web server over here. You could even run like one cluster in multiple clouds if you really felt like it. I need to provide some way of all these workloads to see each other. They've got to have they can address each other and talk to each other. So what Kubernetes does is it provides you an overlay network. And that's actually a big flat network by default, where every workload can talk to every other workload. Now from a security standpoint, you can probably see the problem already. It's a big flat network, and we don't like big flat networks. And weirdly, Kubernetes decided to outsource this. And they said, right, we're not going to do this ourselves. We're going to give it, and there's all these plugins with funny names like Weave, Calico, Flannel, Romana, Cilium. So there's lots of different options for your networking. So each cluster you run into might well be different. They might use different networking setups. So let's talk about security. When I'm talking about Kubernetes security, when I'm looking at how to hack into clusters, I generally look at 3 threat models. I say, there's attackers on the internet, right? There are people outside your cluster. They're trying to break in. They don't have any access to your cluster. Then we've got compromised containers. So if I'm running 500 app containers in my cluster, chances are one of them's going to have a vulnerability in it. Someone's going to break into it. What can they do once they've got that one container? Can they get the whole cluster? And then Kubernetes is a multi-user system. Unlike Docker, you can have privileges. So if I have a user who's got some rights, like I've got a developer, they can create new websites, but they shouldn't have access to the entire cluster. How easy is it going to be for them to do that? How can you stop them? So we'll start with external attackers. So if I'm an external attacker, if everyone's here is a pen tester, you know what you do with systems when you get them. What you do is you port scan them. And if you port scan a cluster, you'll get potentially quite a lot of fun stuff. Depends on whether it's visible in the cloud or not. But if you have these are some of the ports you would see. The main one, API server, is either on 6443, 8443, or 443. Depends on the distribution. Each one's different. So if you see that, that's bad. This one, you can kind of tell it might be bad, right? It's called the Insecure API Server. That's its formal name. That's its name in the documentation. It's called the Insecure API Server. So you'd think no one would ever run that. And then the kubelet's got its own ports as well. But all these things, you know, if I'm a network pen tester and I see that, I'm probably going to have a good day because I've got lots of things to try and attack. And the network plugins, again, they can sometimes open ports too. So, honorable mention, this screenshot probably won't be too visible, but I'll tell you about it. Has anyone heard of, there's a service called Binary Edge, which is kind of like Shodan. And what Binary Edge have done recently is they've added some specific filtering. So if you don't know Shodan, essentially they scan around the entire internet, they port scan a bunch of hosts, like every host they can get their hands on, and then they give you a database, and you can search and say, what can I find on the internet? Binary Edge have done a cool thing where they've added type Kubernetes. So you can actually say, give me all the systems that look like their Kubernetes clusters exposed on the internet. And then they added a really cool filter down here, probably can't see it, which is auth required false. So what they did was they said, tell me about all the Kubernetes clusters that are on the internet without authentication. Turns out there are about 700, 800 people who have left their clusters on the internet without authentication. And they're all cryptocoin mining now, pretty much all of them. They actually do a query where they show you all the running workloads on this, and you can pretty much see the signatures of the cryptocoin miners that these people are running. So there's absolutely systems out there that aren't being secured and just being shoved on the internet. etcd, there's about 3,000 of those without authentication on the internet. Even the Docker, so you know I said Docker acts essentially as root. There are people putting their Docker daemons on the internet without authentication. There's a couple of thousand of those, and they're all cryptocoin mining as well. So basically, if you put your stuff on the internet now, a Kubernetes cluster, the bad guys are absolutely up on this, because this is great for them, right? Because a Kubernetes cluster is great for a cryptocoin mining attacker because it's designed to run new processes. So they just say, give me my cryptocoin mining container. Run that, please. And it does it, because that's what it's designed to do for a living. So yeah, there are people who have made that mistake. And the really surprising thing was, for me, was 390 of those are the insecure port. So it's called the insecure port. And they configured their clusters to list on the insecure port on the internet. There you go. But let's talk about some of the other ones. The API server is kind of an easy attack, but the kubelet's a fun thing to attack. And this one, in terms of, like if you're a pen tester and you think you might see this stuff, the kubelet I still see unauthenticated. I've seen that in the last 6 months, definitely. It's not, it used to be the default that it was unauthenticated all the time. These days, it's less bad, but that's not to say I haven't seen production clusters that have got this unauthenticated. And I said it controls Docker. So let's see what you can do with that. I'm gonna go back to the start of this video. So if you get the kubelet, one of the cool things about Kubernetes testing is it's just curl. You don't need like fancy tooling or anything, because they're all HTTP APIs. All you need is a copy of curl, and you can do fun stuff. So if I run this, yeah. So if you get curl, in this case, I've got a cluster, and it is, let's just click that. So you can do things like give me the container logs. So because this thing manages Docker, it has an endpoint for logs. And you can say, just give me the logs for whatever container is running on my host. In this case, the API server, which we said the API server is super important. So if you expose the kubelet that way, then what you can do is just say dump the logs. And that's not a bad, it's quite useful. And you get that. So you get back the logs, because just executing a command and returning it. That's kind of useful, but obviously it's not as good as actually like compromising the entire host. Fun thing is you can do that too. So we've got this command here, and this it looks a bit complicated, but it's actually not that bad. It basically says, give me the run endpoint, because it's a REST API, so it just has one called run. Give me the namespace, which is just how they organize containers. Then give me the API server and the API server. And then what I'm going to do is I'm going to run a command. And the command I'm going to run is cat etc Kubernetes pki.ca.key, which is, yeah, I'll highlight that. So that is the certificate authority key for the certificate authority that manages the cluster. If you can cat that file out, you can basically take full control of the cluster, because you do certificate authentication and you can just sign yourself a new certificate saying, I would like a new user called cluster admin, please. And it'll give you one. So access to the kubelet very, very quickly leads to full cluster compromise. You can just cat out a file, or you can actually, I mean, the thing is, that command parameter up there, that's command. That's literally run this command in the container. That could be anything you can run, any Linux command, and you are root at that point. So it's run command as root. So essentially this is command execution as a service, and it's very useful. Cool. Other means of acquiring access if you're in the outside world and you don't actually have access yet, GitHub. So obviously people put things on GitHub they shouldn't. GitHub are getting better at like warning you if you do that, but they haven't got around to Kubernetes yet. So typically Kubernetes authentication, if I've got users and I'm giving them rights to the cluster, I give them a file called a kubeconfig file. That was a query I did for things which I know are in kubeconfig files. And I got 636 results. Now most of those were just like templates, but I had a look at a couple and they looked like real cluster data to me. They looked like real users in real clusters. I obviously, not wishing to risk going to jail, didn't try any of them. But the simple fact is, if you've got people who are developing and using GitHub, they might make a mistake and they might post their credentials into GitHub. You need to watch for that. I've seen many cases where customers will post things into GitHub. A common thing I've seen happen a lot is if you develop on GitHub, I've seen companies that do all their development in private repositories, and then a single developer will go, oh, I want to work on this, so they clone it. And then they go, I'm not really ready to put that back in the main repository, so I'll fork it and put it in my private GitHub account. But they do that as a public repository. And then suddenly, all the secrets are being moved into the public repository. So typically we say if you're using GitHub a lot, you need to scan GitHub regularly, and Kubernetes is no exception. So malicious container. Say I've got a malicious container. You know, one of the web apps deployed has got a vulnerability. I've got command execution. What extra things can I do to break into a cluster? I've got an increased attack surface at this point. I have more things I can play with. I've got access to the container file system, right? So if I've compromised one container, I can see whatever is in that container. That shouldn't give me much, but it does. I've got my internal network position, so now I can scan this big flat network and try and find, you know, unauthenticated services. And obviously I can attack the kernel. These are containers, it's a shared kernel, I can do that too. So attacking service accounts are a thing that Kubernetes came up with. It's the second weirdest decision that Kubernetes made with regards to security. There's one weirder one, which I'll talk about later on. With this one, what they did was they said every single container running in the cluster, by default, will be given a JWT token that will be mounted into the file system that has access to the API server. In the old days, those were all cluster admin. So if you're in a really old cluster, you'll find every single one of those is cluster admin, and you literally just get the token and say, thank you, I'm cluster admin. These days, people have worked out to lock those down a bit, but I have started to see clusters where they're making mistakes with the role-based access control, and they're giving these tokens far too much access. So what I tend to do is you get your compromised container, and you go and check and see what access this token's got, and a lot of time you'll find you've got more access than you thought you were going to have. So just to demonstrate that, right click, show controls, speaker. So I'm just going to run I've got a cluster running here, and I'm just going to connect to my cluster and execute a command in it. So I'm going to get myself a new container, and I'm just going to run a shell in it. So I can run a shell inside a container, no problem. It'll warn me about some stuff, but I don't care. And then the fun part is, I'm now going to run another, now I'm inside the container, right? I don't have the credentials I had before, and I'm running commands inside the container. The fun part is, it works. So Kubernetes is very helpful. It sets environment variables in every container to tell processes where to find the API server. And then this kubectl command knows to look for credentials in default locations. So it will go and look and see if it's got a token that it can use, and then it'll use it. So literally, if you get access to a compromised container, download kubectl and run it, and it'll probably work. And if they've made a mess of the rights, you'll have more rights than you think. So at that point, you can get quite a lot of access quite easily. If they haven't given, like, in that case it's cluster admin, so it's no problem. If they've given them less rights, you can still query and say, what rights have you given me? And you try and use that to escalate access. But it literally can be that. So I got a call from someone who was doing a Kubernetes test, and they said, I'm doing a compromised container review, and I just ran that, and it worked, and now I'm cluster admin, and it's 10 o'clock in the morning on the first day of the test. And I was like, oh, well, you've got kind of really easy job now, because you've kind of done. So it's, again, production clusters, it's not unknown for that to be a thing that happens. If you're attacking the kernel, to be honest with you, there have been 2 breakouts. There was Dirty Cow in 2016, there was Wait ID in 2017. There haven't been that many exploits that allow you to get out of a running Docker container, a decently configured one with an up-to-date kernel. Obviously, if someone's super old on their kernels, you can try these. Again, people probably have Linux privilege escalation vulnerabilities, but that's the sort of thing you need to break out. It's not like trivial, but it's definitely one to know about. And leverage, so I want to mention leveraging access in the cloud, not least because this talk was cloudy clusters. Most people deploy their clusters inside AWS, Azure, GCP, places like that. if you've noticed, one thing you might know about AWS, for example, is they have a metadata service. The metadata service lists on a predictable IP address, 169.254, 169.254. Azure and GCP have something similar. And then if you give credentials, so Amazon credentials, to your EC2 machines, which is quite common in Kubernetes deployments. So some of the installers say, give your EC2 machines these AWS rights. You can access those credentials from inside the container. So you can actually say, from a compromised container, hit 169.254, and then get a set of valid Amazon credentials. So commonly on tests now, what we're doing is we're saying, we'll not just try the cluster, we'll try and then break out your Amazon account. I'll show you that. It's really fairly straightforward. So I've got a cluster running in AWS here. And I'm just about to attach to my cluster. So I'm going to attach this cluster. This cluster is running in AWS. And once you're attached, all you need to do, again, this is hacking with curl. I love this because it's like literally if you've got curl, you can do all sorts of fun stuff with clusters. You basically just hit this. And that is a predictable, so that address is always the same. At an Amazon level, you can't block that. There's no facility for blocking metadata access. There are things you can install in Kubernetes to stop it being accessible from inside containers. But if you don't install them, it will be. And then, run again. So yeah, it basically just says, that's the address, those are my credentials, and you can kind of iterate through it till you find it, and it'll give you a list of those names if you ask the directory, and it does that. And it'll dump you, and that's a valid set of AWS creds. And you can then go and you try and use those AWS creds and say, what can I do now? Can that actually let me do anything else? And some of the installers for Kubernetes are a bit notorious for giving a lot of permissions to Amazon as part of the install process. So your EC2 might have, for example, full control of EC2 for that account. So at which point you can create as many VMs as you want. Cryptocoin mining, again, could be great fun at that point. But you can say, how many VMs before the credit card runs out? Where are you? So malicious users. It's harder to stop malicious users from doing bad things to your cluster. But if you've got, so Kubernetes is meant to be a multi-user system. I've seen a lot of customers running big clusters with like 10, 20, 30 apps. Now obviously you don't want every developer to have access to every app. Indeed, you definitely don't want every developer to have access to cluster admin. So you have to try and stop them from getting that. But that's actually quite difficult. By default, out of the box Kubernetes, anyone who has the rights to create a pod is going to be able to get access to the underlying hosts, because there's no facility to stop you doing docker run ---- privileged. That command we did earlier, it just strips away all the security. That's entirely plausible. So basically, you need to add additional features on. There's a feature called pod security policy, which lets you block the creation of things like privileged containers, lets you block mounting the underlying host file system, all that stuff. I will say that I've never seen anyone deploy it yet. So I've literally never seen a cluster where anyone has deployed pods. It is a bit of a picky thing to get working, I'm not going to lie. But without that, you can pretty much, if you're an attacker and you've got the right to create pods, you're going to be able to compromise the cluster, or at least compromise some of the underlying nodes. To give a quick demo of that, let's quickly make it bigger. Okay. So what I did here was I've got a little manifest, which is like just how you create containers, and it's called a daemon set. And a daemon set basically is a type of Kubernetes object where it says, create one of these containers on every single node in the cluster. So one of these containers, I want you to give me one of those in every single node, including master nodes. So you'll get where all the API servers are as well. Once you've got that, you can just say, show me the things you've created, and it's created 2 of them. I've got a 2-node cluster. And then all I need to do is I say, exec into one of those nodes, into one of the pods I've created, just give it the name, and I give it that command. It's the same command I used for the Docker container, chroot/host. Sorry, actually, yeah, I'm going to get that wrong. That's host, yes, host. Chroot/host. And it does it. And what do you notice? I'm root on the node. So I'm just the root user at that point. I'm the unconstrained root user. I've got full access to that machine, and there's 2 nodes in that cluster, but essentially I've got root on both. So with a single manifest, you can essentially take root access on a 100-node cluster on every single node at the same time, if they've not deployed pod security policies. So that's why pod security policies are so important, because if you don't, people do that to you. The interesting thing about, or one of the interesting things to me about this, is people expose their Kubernetes clusters to the internet a lot. There are, I think, a conservative estimate, there's a couple 100,000 Kubernetes clusters. You can tell from the SSL certificates that it's a Kubernetes cluster, and there's a couple 100,000 of them online. So if any of their credentials go missing, then you can head it online and you can do that. So it could be quite bad. So how do we fix all this? We've said we've got a lot of problems. There's lots of things we need to think about. If you're deploying Kubernetes, and as I've said, I've seen a huge number of companies doing this. So I was at KubeCon EU like about 3 weeks ago, and there were 7,700 people out there. The previous year it had been, I think, 4,000. The previous year it had been 1,400. So there's a huge growth and interest in this. So if you're not running Kubernetes now, you're probably going to run across people running it pretty soon. So what do you need to worry about? You need to lock down the API security. That's absolutely like table stakes. The very first thing you want to do is get those APIs I talked about and make sure they're not available unauthenticated. Make sure you've got your authentication configured correctly. And they're not easily accessible. Then we get to API server authentication. This one has the weirdest thing about Kubernetes security that I've found. So Kubernetes, by default, within product, provides 3 ways of authenticating. It provides basic authentication, which is clear text credentials in a file. It provides token authentication, which is clear text credentials in a file. And it provides client certificate authentication. So obviously of those 3, people go, oh, well, client certificate, that's obviously better. There's one small problem. Kubernetes doesn't have certificate revocation at all. So if I issue a client certificate with a user, I say, here's your client certificate for authenticating this cluster, and then they leave the company in 3 months' time, or they move jobs, or they lose their laptop in Starbucks and it wasn't encrypted, the only way to defeat that is to re-roll the entire cluster. So basically blow away the entire certificate authority and go from scratch. That's the only, and to this day, there's an open issue on GitHub that's been open for 4 years, which says, can we please implement certificate revocation? And they haven't. So it's probably not going to happen now. If you're doing this and your company's wanting to do this, the answer is use an external authentication service. So they can hook into like Active Directory, or you can hook into like Google or GitHub or something. Do not use the inbuilt authentication options because there's no good ones. And their opinion is they kind of regard that as not their problem. I disagree respectfully, but that's obviously their software. Authorization is important. So obviously once you've got your users, you need to make sure they can only do what they need. RBAC is a bit of a complicated beast. It's quite easy to make mistakes. A good example of how you can make an easy mistake is you might have an account that was, say I want to give someone read-only access. So you say, okay, at a cluster level, let them read things. Now that sounds quite safe, right? It's read-only access. But Kubernetes is an object type called secret. So if you give someone read-only access, they can just dump all the secrets out of the cluster. And that's all the passwords and all the credentials and everything else. So read-only access isn't safe as a Kubernetes option. So you need to really think about how you implement RBAC, because it can be quite tricky. Other things to think about in Kubernetes. Pod security policy I've mentioned, it's super important. Without pod security policy, basically everything goes horribly wrong. If you've got multiple users, if you're doing everything with like a CI/CD pipeline, so like no ordinary user should be getting there, you can do the checks elsewhere. So you can do the checks in your CI pipeline. It's not too much of a problem. But if you've got multiple users, you need that. And network policy is a feature that lets you get rid of that big flat network. So you can actually lock it down and say, you know, hey, every app doesn't need to talk to every other app. You can implement network policy to add ACLs to your cluster. Other related things, because Kubernetes has a kind of like an ecosystem of products now. The Cloud Native Computing Foundation has tons of products. And some of them have some what I can only describe as slightly questionable security choices. The first one to know about, because this is quite common, is Helm and Tiller. Helm is a package manager for Kubernetes. It lets you deploy, so they'll have like charts that they say you can install an entire system with this one chart, and you just run it, and it works, and it deploys on your cluster. By default, the Happy Path installer says install this Tiller component inside your cluster with the rights of cluster admin, and then don't turn authentication on. So if you can reach the port that Tiller runs on inside the cluster, you get cluster admin by default. You can just say, you can give it anything you want and it'll just run it. So I have seen this in production clusters recently, as in 2 weeks ago. Most people who deploy Tiller don't do it securely because it's kind of complicated to do securely, so they just do it that way. Jenkins, other thing I see all the time when I do cluster reviews, I see Jenkins because people use CI/CD along with this stuff. Jenkins security has its own topic. I can get someone to do an entire talk just on Jenkins security. But it's just something where you'll see a lot of rights being given to Jenkins. You then have to be careful that developers can't say, my rights in Jenkins let me deploy containers. I'll just deploy a privileged container to every host. And away you go. So that can be something to think about. The last one is worth mentioning is Prometheus. Prometheus is a monitoring tool that the Cloud Native Computing Foundation support. I see it a lot in clusters. The reason I mention it here is the Prometheus team's attitude to authentication is that's not our problem. They actually had a security review where the reviewer said the code quality is good, but we question the fact that they've decided they don't have to worry about authentication. So if you deploy Prometheus, or your developers want to deploy Prometheus, you have to go and do your own like reverse proxy or something and set it in front of it to stop people being able to basically get hold of. It gives you at the very least a huge amount of information disclosure, because it's got information on all the clusters and the applications running on it. So you have to be quite careful with that as well. Resources, things you can use if you want to get involved in Kubernetes security. Some ones that are worth mentioning. The CIS benchmarks are not a bad place to start. They're a bit wordy, like all CIs. If you ever use CIS benchmarks, they get a bit wordy, but they do have quite a lot of good information. There's also some tools from Aqua Security, KubeBench and KubeHunter. KubeBench is like it'll let you assess your cluster against the CIS benchmark. It doesn't work on every cluster, but it's worth looking at. And KubeHunter is just a little pen testing tool. So if you want to like automate some of the things I've been doing here, like I want to try, it'll tell you whether your kubelet's available and authenticated, and it'll let you try and attack that. So you can do that as well. Conclusion. So things to take away from this talk is containers are just isolated Linux processes. They're not magic. There's nothing funny about them. It's just a tarball that's being run in Linux with some constraints. Literally, that's it. Most of the attack surface for these things is REST APIs. So if you think about how you would, if you're a pen tester, basically you just need curl. You can use the tooling as well, but curl will do for most of this. You don't need a whole lot of fancy tooling. And the other thing I'd say is this is a really rapidly developing area. So Kubernetes is on a 3-month release cadence. So they do a new version every 3 months. Also, if you're deploying this, worth noting, they only support the current release and the previous 2. So you have to be ready to upgrade every cluster every 9 months if you want to stay in support. There is no long-term support release available from any vendor. Maybe Red Hat might do one, but I don't think so. Right now, there is no long-term support. So you have to be in a position where you're happy to redeploy. Docker is slightly better in that I think if you can get like a 6 months, actually that's probably 6 to 9 months as well. It's a year for their enterprise version. So basically, for all this software, if you are deploying it, you have to be super sure that you can re-roll stuff really it's not something where you put it in and leave it for 5 years. That won't work, because it'll be vulnerable, and they won't do security patches beyond 9 months. So the next time the security vulnerability comes out, if your cluster is over 9 months old, it's rushed upgrade rather than planned upgrade. Cool. Questions? I don't know if we've got time now, or if not, I've got my Twitter handle there, email there. Always happy to take any questions on container security. If there's any now also, I think we've got a couple minutes, yeah? Yeah, a couple minutes.
You mentioned earlier about Jenkins. What are your comments in terms of the Ansible or Puppet or Chef in terms of automation CI/CD? In terms of security perspective?
So, yeah, there's a lot of installers that use Ansible, Puppet. Basically you can find a way of deploying Kubernetes under any of those. It probably isn't, those installers probably don't have too much effect on the cluster security itself. So any of those would probably be, you really have to look at each individual installer and find out, what it does. You can't say across technologies it's like this or that. It will depend, I think is the answer. It's not a great answer, but unfortunately that's the